Hello everyone. In this session, we will discuss about the current mirror. So name itself, it is a current mirror. Mirror means, what do you know about mirror? If you look at any object in the mirror, the same representation will be represented in the mirror. That means the copy of the image will be shown in the mirror. Yeah, here also current mirror means if you give some current to the current mirror circuit, automatically the same characteristics of the current will be delivered by the current mirror. That means, observe this circuit. Here current mirror is a circuit. It will take some reference current and it will generate the copy current. That copy current has same characteristics as the reference current. So the title itself, current mirror, means the same characteristics of the current will be delivered or developed by the circuit. That's why it is called a current mirror. So here, once we will look at the definition, current mirror is the active circuit. So it consisting of the active elements which senses the reference current. So it will take this reference current and generates the copy or number of copies. So it will generate one copy or number of copies of the reference current with the same characteristics. So characteristics must be same as the reference current. Copies will be increases. Here, look at here, the copy current will be same as the reference current, or otherwise n times of the reference current. So it will generate number of reference currents, okay, or 1 by n fraction of the reference current. That means, for example, if the copy current is equal to 5 amps, for example, and the reference current is 5 amps, the copy current, generated current may be 5 amps, or the copy current may be 10 amps or multiples. So that means 15 amps or the 20 amps, or otherwise the copy current may be 2.5 or 1 amp, like that. So any reference, it consisting of some reference currents will be generated. So this is the importance of the current mirror. Here generally this copy current is stable as the reference current. So it depends on only the reference current source. So reference current source is stable, automatically copy current will be also the stable. At any case, it can be designed by using the BJT only. So in order to get the reference current, we are using BJT only. So look at the BJT here. You know that generally we are using here common emitter BJT. That's why emitter is like this. This is the base, this is the collector, and the input voltage is the VBE, and positive is for base, negative is for emitter, and the generated current will be the collector current. Okay, here the output current, collector current, can be named it as the output current. Yes, this output current can be written as Is e power VBE by VT. How we can return this collector current will be approximately equal to the Is into e power VBE by VT. What is VBE? VBE, you know that, base emitter junction voltage. Base emitter junction voltage. And what is VT? This is temperature voltage. Temperature voltage constant. Yes. What is Is here? Is is reverse saturation current. Reverse saturation current. What is this reverse saturation current? Reverse saturation current depends on the minority charge carriers. Whenever minority charge carriers increases, automatically reverse saturation current will be increases. So IC equal IS e power VBE by VT. So in order to control this current, we can control by using the VBE. So here itself, so by controlling VBE, collector current can be controlled. That is the important point here. That's why we are that's why we will take a BJT here. That BJT consisting of the collector current. So these collector current, this output current can be controlled by this reference current. So we have to, this is our mirror circuit. This is our mirror circuit. We have to design this mirror circuit. This is our mirror circuit. So by using this mirror circuit, we can control the current of this BJT. We can control the current of the BJT. So by using the reference current, we have to control the current of this BJT, right? So we have to design this current mirror circuit. So for that purpose, so we are designing, look at here, for that purpose we are taking a transistor, the transistor having, name it as Q reference. This is the reference transistor. Here two transistors, collector and base, will be combined together. Collector and base will be combined together, and both are will be same potential. Both are will be same potential. Okay, and it will take reference current from the current source I reference. So this is the reference current source, and this voltage is the VBE reference voltage, and this is applied to the same VBE1. Why it is VBE1? It is a transistor which has the Q1, which is the named with the Q1, and it will generate the current IC1, which will generate the IC1 collector current, and these both base terminals will be connected together. Okay, so by using this, so by using the circuit, both collector current and reference current will be the same. This IC1 and I reference both will be the same. Okay, so in order to do this, in order to understand by mathematical calculations, we have to do the sum calculation. That is, so here first, for reference transistor, for just analyze for Q reference, that means it is for the reference transistor. Assume that base current is negligible, there is no base current, just assume simply. So whenever the base current is negligible, automatically what happened, the collector current must approximately equal to the reference current. Collector current must be equal to the reference current. Why? Reference current will give collector current as well as the base current, but here by removing this, both will be approximately same. Okay, so by using this phenomena, we can write the collector current equation. Again we have to write the collector current equation, that is IS reference, that means reverse saturation current, and exponentially VBE by VT, VBE by VT. But here both collector current and reference current will be same, that's why it is equal to the reference current. Here you know that the reference, this is the reference current, and reverse saturation IS are, so just write VBE reference, we can take IS reference, reverse saturation current of the reverse saturation current of reverse saturation current of Q reference, that means reference transistor, Q reference, right? So from this we can write the another equations. We can design some more equations. Those are, from this we can write VBE reference value. What is VBE reference? Generally we can find out this is also the reference, this is also the reference value. Okay, by solving this we will get VBE reference value. What is this VBE reference value? VT into natural log of I reference by IS reference. I reference by IS reference. Okay, so this is the final value. But here if you observe here, VBE reference and VBE both will be same. Look at here, this voltage will be same. So you can take, we can write it VBE reference equal to VBE1. Assume as VBE, just take all R will be common to VBE. Then you can write, then you will write IC1 also. You can write IC1 value also, that IC1 equal, both are same simply, so you can write so leave that, so just write this equation. Before that just write this equation, that is VBE, you should take as VBE, you will get VBE reference here. So from this directly I can write, this is know that, but I reference we will take the equation like this. First equation, from this equation just write the equation same as I reference equal to approximately equal to IS reference exponential of the VBE by VT. VBE by VT. Take it as the first equation. Take it as the first equation. Okay. Next we have another transistor, that is for Q1. For Q1 means for this transistor, for transistor 1. Now we should write for transistor 1. Here the transistor 1 I can write the equation IC1 equal to IS1 exponentially VBE by VT. VBE by VT. So for this is Q1 transistor. Okay, for this is Q1 transistor, take it as the second equation. This is the first equation and this is the second equation. Okay, our intention is, generally if you look at this transistor Q1, always our transistor, our load transistor must be in the active region. Always maintain Q1 in active region. Q1 in the active region. Okay, so we are getting two equations. So we will write some statements here. The first statement here, for Q reference, that means for reference transistor for Q reference and second for Q1 transistor. For Q reference, if you look at the reference here, this is the reference. Generally we are giving input and we will get output here. For Q1 we are giving input and we will get the output here. Just write those statements. Here what is input? Input is reference current generally. And what is the output? Output is VBE reference. We will get the output. But what about Q1? Here input is VBE1 is the input. What is output? Output is we are getting IC1. So if you observe here, it will take the input current and it will give the output is the voltage. So I can write this complete system will be, for Q reference transistor, it will be acts as current to voltage converter. And here it will take the input is voltage, it will give the output is current. I can write this is the voltage to current converter. This is current to voltage converter, and for Q1 is voltage to current converter. So by using this already we are getting two equations. For Q1, for reference we are getting the reference current is IS reference exponentially VBE by VT, and first transistor IS1 exponentially VBE by VT. So we are getting to, by doing, so in order to get some relation, by doing a ratio between those, that is IS1 by I reference, what we will get finally? So IS1 by IS reference, IS1 by IS reference. So from this I can write IC1 equal to IS1 by IS reference into I reference. So this is the equation we are getting. If you observe the equations, no need to assume here. Generally Q reference and Q1 are identical transistors. These are identical. Then what happened? IS reference and reverse saturation current of reference transistor and first transistor both are same. Then finally what happened? Then finally we will get first transistor current and reference transistor current both are same. Yes, yeah. So reference current and Q1 are identical transistor. Finally we will getting first transistor collector current, reference current both are same. That's why by controlling this reference current we can control the output current of the transistor 1. Here we can discuss some cases, that's why we will understand easily. For case 1, Here for case 1, generally this reverse saturation current of any transistor will be depend on area of emitter base junction. Area of emitter base junction. Yes. So here we can write the first, for example, first transistor is 5 times of the reference transistor current. Reference transistor current. What happened? For example, transistor 1 reverse saturation current will be 5 times of the reference transistor current. Then the collector current IC1 can be written like this. The formula is IS1 by IS reference into I reference. So from this, by substituting the values, we will get collector current 1 IC1 equal to 5 times of I reference. 5 times of I reference. Yeah. Okay. We will discuss the same case 2. We will discuss the case 2. If area of Q1, if area of Q1 is 1 by 5 times fifth of the reference transistor, then what happened? The first transistor current equal to 1 by 5 times of the reference transistor current. Okay, area increases, then automatically the output current will be increases. Area is decreases, automatically the output current will be decreases. So emitter base junction area will be decides the reverse saturation current, that will be decides the output current. Okay, so this is about the current emitter, current mirror. Okay, I hope all of you understand the session. Thank you.